All right, your first couple examples, I believe this is just the simplify section?
Yeah.
Or is it the get rid of the denominator section? Or
That's
right
40,
as a,
that's 30.
that's in the 40s, right? All right, so regardless, and this is going to apply to 5-2 as well. You have two fractions here. You need to get those fractions together. So in order to get fractions together, they need to have like denominators, common denominators. So you need to make a common denominator. It doesn't look like there's anything tricky here. It's just one factor. So you're going to take the factor from the right-hand denominator and multiply it into the left-hand denominator. Same thing goes left to right. So we need to multiply by something that is not going to change the value of the fraction. So what do you multiply by that does not change the value of a fraction? Or the value of anything, really? John?
1.
Multiply by 1. We need a fancy form of 1. What's our fancy form of 1 here?
Secant x minus 1 on the numerator and denominator.
Good. Same thing, numerator and denominator. And we're going to do the same thing over on the right-hand side. We have secant of x minus 1 on the right, so we're going to multiply by this guy over itself. Secant x plus 1 over secant x plus 1. When we put these things together, make sure you distribute correctly. You're multiplying one term times two terms. So our new numerator over here on the right is secant of x minus 1. And we know what's going to happen. The point of this was getting the denominators together, so we might as well go ahead and combine it right off the bat. We have secant x plus 1 and secant x minus 1. That should be somewhat of a familiar form to you, even though it's got this secant thing in it. And then what's your other numerator? So we put the denominators together. That was our purpose of multiplying by this fancy form of 1. We have the left-hand numerator, secant x minus 1. Now we need the right-hand numerator. So we have plus secant x plus 1. What can we combine in the numerator? We have secant x minus 1 plus secant x and plus 1. We have two secant x's, absolutely. So we're going to write two secant x's. We have negative 1 and positive 1. So we no longer have 1's. Now your denominator, what do we call this? We talked about it yesterday. We have secant x plus 1 and secant x minus 1. Something plus something else, and then that same thing minus that other something else. The difference of two squares. Good. Now what happens when we multiply the difference of two squares? I don't know if there's a benefit of doing that. I don't know if we're going to get any simplification, but you should recognize that this is the difference of two squares. And when you have that, what happens? Yeah, it's the first term squared minus the second term squared. We don't like having 0 in there. Most of us would not have written 0 to begin with. So we're just left with 2 secant x over secant squared x minus 1. And now we're going to cancel the secants out?
No.
No, we are not going to cancel the secants out. This guy has 1 subtracted from it. There's nothing we can do there when you have addition or subtraction in your denominator. Once you see that, you pause, you leave it alone. Unless you have secant squared x, which is down here in the denominator, you have exactly secant squared x minus 1 as a factor in the numerator. That is the only time that you can cancel things out, but it would be the entire term, secant x squared x minus 1, that gets canceled out. We don't have that, it's just secant x by itself. Well, there's 2 of them, sure, but there isn't any addition or subtraction, so that is as far as you can go.
Wait, what?
No, can't you?
Oh, you want to do more?
Yeah.
All right.
Would you accept that on the test?
That's what I was thinking.
What's secant squared x minus 1?
Secant squared.
Okay.
This is where it gets complicated. Yeah, now I get it. And then you know what?
What do you want to do? take it further. So let's go up here so that we can see what happens. So we have 2 secant x over tangent squared x. You want to do, Captain? 2 times 1 over cosine? And if you are changing secant x into 1 over cosine x, what are you doing with tangent squared x? Sine over cosine? Squared. Okay, so this is tangents. Now, we're going to make this messier initially, because now we have a fraction inside of a fraction. But
Multiply by the reciprocal.
you could multiply by the reciprocal, absolutely. So we have 2 times 1 over cosine x times, what's the reciprocal of sine squared x over cosine squared x? Cosine squared x over sine squared x.
So for any of these identities, the squared version also works for it?
Yes.
Okay.
You can go from a power of 1 to a power of 2, but you can't go backwards necessarily.
Okay.
So when you're looking at your identity sheet and you see cosine equals 1, what do we have here? We have secant equals 1 over cosine squared. We could also say that secant squared x equals 1 over cosine squared x. That's okay. So what happens here? We are dividing by cosine and multiplying by cosine squared.
You cancel out on the cosine.
One of the cosines gets reduced. So we're left with 2 cosine x over sine squared x.
Unless you know what cosine can.
Now we can keep going here, right? One of the strategies was to turn everything into cosine and sine. So this looks good. What else could you do with that though? Keyword?
You could, I guess you could do it so it's cosine x over sine x multiplied by 1 over sine x.
So we have 2 times cos x over sine x times 1 over sine x.
Yeah.
Sounds like a mucus kind of thing.
A mucus kind of thing?
Like one of those like nasal
Like
sprays.
mucinex?
Yeah, but it's sine x.
What's cosine over sine?
Tangent.
So we have 2 cotangent, and what's 1 over sine?
Plus secant. Dang. That went super far.
It did go super far. Now, is there one I'm going to accept over another? I don't know. I don't know which one is preferable. The point of this is to evaluate. So is it easier to evaluate cotangent and cosecant or cosine and sine? For me, it's easier to evaluate cosine and sine because I can go back to my unit circle easily. I could also type it into my calculator easily, and some of my calculators don't have cotangent and cosecant in it, so they may be tougher to work with. So for me, this is the preferable one if we're going to evaluate. If you're talking about total simplification, get rid of the denominators, make it look as nice as possible, it's probably the 2 cotangent cosecant one. 36 has a similar idea here. Here we had secant x plus 1 and minus 1. There we have cosecant x plus 1 and cosecant x minus 1. So what are we going to do to combine our fractions over here?
Same thing.
Multiplied by cosecant x plus
What are you going to multiply by?
cosecant x minus 1.
X minus 1 and cosecant x minus 1.
And the other pair by cosecant x plus 1.
A lot of letters with trig. All right, what do we have? When we multiply sine x times cosine x minus 1, what do we get?
You get sine x cosine x minus sine x. Cosecant.
And on the right-hand side, what do we get? One big old numerator here. We get plus, Again, sine x cosecant x plus sine x. What do you have in your denominator? You have exactly that thing times the opposite of itself, so let's simplify. Instead of saying this thing times this thing, we could say, since we know it's the difference of squares, we could write it as cosecant squared x minus 1. Now look at that alphabet soup in the numerator. Sine x cosecant x minus sine x plus sine x cosecant x plus sine x. What's one thing that happens, Marissa?
Becomes 2 sine x.
What do we get?
2. Wait, no.
It's a great thing that happens
wait.
for a day like today.
2 sine x cosecant x.
Yep, we get 2 sine x cosecant x, and what else happens, Jordan? She took it up? Let's get to that in a sec. I like that.
Sine x cancels out.
What happens?
Sine x cancels out.
This we are now without sin. No more sine x. All right, so now we're seeing something squared minus 1. We should be thinking the phrase that the textbook loves. What's that? The Pythagorean identity. And what's the Pythagorean identity again for this one? Cotangent squared x. All right, so we can rewrite the denominator as cotangent squared x. Now, Jordan, what do you want to do in the numerator? Change cosecant to 1 over sine x. That looks pretty good because now we're going to have sine x times 1 over sine x. And now you're multiplying something by its reciprocal. And when you do that, what do you get?
Don't you get rid of it?
You get rid of it because what happens? What is the product when you multiply something by its reciprocal? It doesn't disappear. It's 1. So we have 2 times 1 over cotangent squared x. I don't know if do we have anything for cotangent squared? 'Cause right now we're at 2 over cotangent squared x. We just turned something into cotangent squared. What do you say, Amanda?
Can you do tangent, or you could do cosine over sine, whichever one you do.
Can't you just
Or you kind of trailed off there.
Can you just change, since it's cotangent, into 1 over tangent, or you could change it to cosine over sine.
So you could write this as 2 times 1 over cotangent squared x. Is there an identity for 1 over cotangent squared?
I'm sure there's
Yes.
tangent,
Tangent squared x.
What is it?
tangent.
Where are you finding that in your reference sheet, Amanda?
In my reciprocal identities.
In your reciprocal identities, 1 over cotangent squared is tangent squared. So we actually end up with 2 tangent squared x. You want to write that over as sine squared over cosine squared? Go right ahead. I think that looks more confusing. I would rather leave it as 2 tangent squared x.
Do it, Mr. Phelps. Do it.
No, I'm not going to do it.
Peer pressure.
All right? Now, Kelly, 38 is not going to be in our viewing window, is it? Because the squiggle was like right here. Where's the catch it? 38 says sine over cosecant over cotangent.
All right.
Got it, Marissa? See 38 on there? All right. I don't know. What do you want to do? You want to multiply.
Wait, hold on.
Great.
Mr. Tufts, I have a
There's a
question.
minus.
There's a minus in between.
What? Who's forgetting minuses? I'm Mr. Krowski.